So now we're going to look at inequalities with quadratics when there's a square term in the inequality, and it's going to be similar to solving it when there's an unknown in the denominator of a fraction. Essentially, we're going to look at it and find the points of interest, and then we're going to uh, actually test those intervals, and then we're going to see if the inequality is true for those intervals or not. So this first inequality that we've been given to solve is x squared minus 7x plus 10 is greater than 0. And we want to find our points of interest, and the way that we'll do that is by factoring. And it's going to be pretty straightforward, but we'll give you a reminder of how to do that factoring here. We have to find the factors of positive 10 that will add up to a negative 7. So for a positive 10, we'll have 1 and 10, 2 and 5, and then we'll also have a negative 1 and a negative 10, because negative 1 times a negative 10 is positive 10, and negative 2 and negative 5. And then we're looking for the factors that when they are added up will give us a negative 7. And that's pretty straightforward. I mean, you can see it's this last one here, the minus 2 and the minus 5. So then we could factor that and say x minus 2, x minus 5 is greater than, sorry, not greater than or equal to, it's just greater than 0. So our points of interest are going to be when x is equal to 2 and x is equal to 5. So we'll want to look at these intervals here within those values of x. So we'll have to look at the interval from negative infinity to 2. And we'll leave that as a parentheses right now because we're not sure if that's going to be equal or not. Then we'll look at the interval from 2 to 5. And last, we'll look at the interval from 5 to infinity. All right, so this first interval, negative infinity to 2, well, we'll test that with x equals 0, right? It's going to be easy. 0 minus 0 plus 10 is greater than 0. So that's going to be true in that interval. So we'll end up with 10 is greater than 0, so that checks out. Now we'll want to look at when x is equal to 2 to see if that should be included or not. So x is equal to 2, you get 2 squared minus 7 times 2 plus 10. Is that greater than 0? Well, you've got 4 minus 14 plus 10. That's equal to 0. So no, that's not true when x is equal to 2. So that interval is correct just the way that it's drawn here as negative infinity to 2 with a parentheses. So the next interval that we'll want to check is this 2 to 5. So we'll say, x is equal to 3. We'll just pick that one. So then that gives us 3 squared minus 7x. And of course, x is 3. So 7 times 3 plus 10. Is that greater than 0? Well, you get 9 minus 21. 21, not 27. Kind of looks like a 27. 21 plus 10. Is that greater than 0? Well, no, because you'd end up with 9 plus 10 is 19, so then that's a negative 2. So that's not in that interval. So that interval does not make this inequality true, is what I intend to say. So that's not going to make that interval true. So now we look at the interval from 5 to infinity. So we'll look at it and we'll pick, okay, we'll say x equals 6. So we get 6 squared minus 7 times 6 plus 10. Is that greater than 0? Well, you get 36 minus 42 plus 10. So 36 plus 10 is 46 minus 42, so you end up with 4, and that's greater than 0, so that checks out. So now we'll have to test for 5 to see if that should be included or not. Pretty sure it shouldn't be because none of this interval is true, but just as a final double check, you'll get 25 minus 7 times 5 is 35 plus 10. Is that greater than 0? Well, no, that's equal to 0. So it's also the parentheses 5 and infinity. So our solution sets are the interval negative infinity to 2 and union we'll draw a union here because it's also with 5 to infinity. And the union symbol here, that shows that it's this solution set, the negative infinity to 2, this interval, and this interval of 5 to infinity. So it's both of those. And the U here just stands for union, and that's a way to show that it stands for that both of those intervals. So if we come to our graphing program here, and we say x squared minus 7x plus 10 greater than 0, you can see this is the interval that we just talked about. Negative infinity to 2, and it's a dotted line because you don't include 2. And then you also have a dotted line here at 5, and that's shaded into infinity. So that's how we would graph our solution set to that first inequality. So now our second inequality that we're being asked to solve or find the solutions for is 2x squared plus x is less than or equal to 15. And the easiest way to solve something like this is we're going to subtract 15 from both sides of the equation and have that inequality set to, and we'll test it against 0. So then we'll say, come down here, and we'll say 2x squared plus x minus 15 is less than or equal to 0. Well, we'll factor this again. This one will be a little bit trickier because there's a 2 here, but it's not much. It's the same idea here. So the factors of the factors of 2 are 1 and 2. The factors of negative 15 are negative 1 and 15, negative 3 and 5, negative 5 and 3, and negative 15 and 1. And when we want to find the factors of negative 15 and 2, that when added together, when multiplied and added together, give us a positive x. Well, if we look here, we can see a 1 times a negative 5 is negative 5, and a 2 times a 3 is a positive 6, and 6 minus 5 gives us a positive 1. So those are our factors. And we'll write that as, we'll put a 2x here, and an x here, and then a positive 3, and a negative 5, less than or equal to 0. So now our points of interest are going to be when x is 5/2, and when x is negative 3. So our tests that we'll have to do for the intervals, we're going to be looking at 3 different intervals. We're going to be looking at the interval from negative infinity to negative 3. We're going to look at the interval from negative 3 to 5/2. And then we're going to look at the interval from 5/2 to infinity. So we'll start off here with this first interval. Um, we'll pick x equals -4, and we'll say 2 times -4 squared plus a -4. Is that less than or equal to 15? Well, -4 squared is 16. 16 times 2 is 32. 32 minus 4 is 28. So 28 is not less than or equal to 15. So that region is not true. Oh, yeah, remind me later. So then we've got the region -3 to 5 halves. Well, again, x equals 0 falls in that range. Easiest to test. 2 times 0 squared is 0 plus 0. Is that 0 less than or equal to 15? Yes, it is. So now we know that that region is true. And then we'll look at this region 5 halves to infinity. We'll say x equals 3, because 3 is 6 halves, so that's going to be more than that. So 2 times 3 squared plus 3 is that less than or equal to 15. Well, 3 squared is 9. 9 times 2 is 18. 18 plus 3 is 21. So no, that region, that interval is also not true. So now we know that this interval is -3 to 5 halves, but now we really need to check to see if this interval includes, this solution interval includes -3 to 5 halves, or if it does not. So when x equals -3, let's scroll down a little bit here. When x equals -3, you'll get 2 times -3 squared plus a -3. Is that less than or equal to 15? Well, -3 squared is 9. 9 times 2 is 18. 18 minus 3 is 15, so yes, that includes -3. And then when x is equal to 5 halves, this one will be a little bit more fun because it involves fractions. You'll get 2 5 halves squared plus 5 halves. Is that less than or equal to 15? Well, 5 halves squared gives us 25 fourths plus 5 halves. Those twos will cancel out, so you get 25 halves plus 5 halves is 30 halves. 30 halves is 15. So it also, and 15 is equal to 15. So 5 halves is also included in that solution interval. So our solution interval, our lone solution interval in this case, is going to be the interval when x is equal to -3 and when x is equal to 5 halves. And that's in that interval from -3 to 5 halves. And we have brackets to show that -3 and 5 halves are included in our solution. So if we go to graph it, we'll get rid of the old one here. We'll get 2x squared plus x less than or equal to 15. And there you see our solutions from -3 inclusive, it's a solid line, to 5 halves, which is 2.5, the solid line, and everything in between. That's our solution set for that inequality. So that's how we have to solve inequalities involving quadratics. We have to find the points of interest, and then we have to test those points of interest to see if the range, to see if the intervals, to see if the intervals make the inequality true or not.